So thanks everyone for attending today's webinar on migrating Microsoft applications to AWS like an expert. My name's Danny Jenkins and I'm a solutions architect based out of our Sydney office. So today's session is a 300 level session. So we're not going to be really focusing on the value proposition of the services we're going to be talking about. What we are going to be doing is following an entire migration of a number of Microsoft workloads for a fictitious organization called Unicornshop. Now, we're going to be moving pretty fast across an entire migration and are potentially not going to go deep enough into specific areas. So the Unicornshop.lol website is live now, and that'll stay live. And what that does is it has a quick link section that maps directly to the content that I'm going to be going through today. So if you hear something and you think that's quite interesting, but you're not too sure what it is or where it fits, do check out that website, and then you can dive a lot deeper into the particular content that makes sense for you depending where you are on your migration journey. So who are Unicornshop? So Unicornshop are unfortunately a fictitious organization, but they have the vision of enabling everyone who wants to be a unicorn to at least be able to look like one. They're moving into brick and mortar stores. They've got an online e-commerce offering. And like a lot of customers I work with, they're tired by wasted resources in their data centers. They're moving into an OpEx model rather than a CapEx model. And they have developers that want to help the business, but they're being frustrated by being held back by what they see as unnecessary controls. So today what we're going to do is walk through an all-in migration for Unicornshop. And how we're going to do that, we're going to start off by looking at some of the applications that we're going to be migrating across. We're going to have a look at the approach that we're going to take, and then we're going to spend a large chunk of today's time looking at that landing zone build out with a real focus on automated governance. We're going to have a look at Active Directory, migrating our databases across on our application tiers, before looking at a quick automation win, before wrapping up with some of the next steps following a migration. Now with that jam-packed agenda defined, what are we migrating across? Well, the first workload is their web store. Now this is a PCI Compliant web application because they're processing credit card payments. It's a .NET front end with a back-end SQL database. And the second application we're looking at migrating across is their CMS system. Now again, this is a three-tier structure and it's web-facing, and as such it has a legacy threat management gateway fronting it. Now there's some particular pain points here that I want to call out. Firstly, that threat gateway is a single point of failure, and secondly, Unicornshop is struggling to keep up to date with the threat definitions on that device due to the ever-increasing rate at which these threats are evolving in today's modern world. And the last set of workloads are a bunch of microservices. Now these are all running on Server 2012. We've got a mix of some full .NET applications and some .NET Core applications. And they take their inputs via web logs and database logs, and their outputs are via things like Salesforce Insights, exposing business insights to things like Tableau, Power BI, as well as exposing some RESTful APIs that their vendors can consume for things like inventory updates. Now with any good migration, there needs to be a strategy. We need to know where we're heading, but more importantly, we need to know why we're heading there. Now, your migration should be broken into a strategy piece, and there's a great video on that Unicornshop website that talks about building that business case for cloud migration. Then we need to do planning and discovery. Now, in my migration, I've already sussed out what workloads that I'm migrating across, but if you haven't, the AWS Application Discovery Service is a great way to understand what your application dependencies are. So if I have two applications, how do I know whether they're talking to each other? At a network layer, the Discovery Service can really help us out with that. Today's session, we're going to be mainly focusing on build and migrate, although there's a huge amount of benefit that can be gained by looking at the run state and looking at services like CloudWatch and AWS Config as soon as we start moving off of that off-ramp following a migration. Now, our approach to this migration will focus around the 6R migration approach, which is core to the AWS Cloud Adoption Framework. Now, this framework was created to help organizations develop efficient and effective plans to help with their cloud adoption journeys. Now, I've again linked to content on the website that explores this in depth, but one aspect of that comes into play is when we assess a workload, we need to decide which bucket is it going to sit in. Are we going to retain this workload? Are we going to replatform it, retire it, refactor it, rehost it, or even maybe repurchase it into something like a SaaS offering? Now, our approach for Unicornshop will be a little bit of a mix. We're going to do some refactoring, but also a lot of rehosting. Now, if we were using SharePoint as an example, We can't just translate that front-end logic into Lambda and migrate our SQL database to a schemaless NoSQL database and high-five our colleagues that we're running serverless. Now, some workloads do still require a bit more of a traditional approach, and that's absolutely fine. So where are we going to put all of these new workloads that we plan to migrate across? Now, getting your landing zone mapped out beforehand is absolutely vital. And working with some of my customers, too often I see single accounts with prod, dev, test, and security-averse workloads all sharing the same account. So we're going to take a look at multiple accounts, focusing on the security piece, diving down specifically into AWS organizations and service control policies. We're going to build out a monolithic approach to identity. We're going to have a look at how guard duty can help us with governance and some event execution pieces. We're then going to have a look at a quick demo on how config can help us with one of our requirements for our PCI web application before looking at some of the connectivity that's required to support this migration. After that, we'll start moving on to the next tier of our migration. So if you aren't using organizations today, you absolutely should be. It's a fast evolving service and does today and has aggressive plans to remove a lot of that heavy lifting around centralized account management. Now in this OU structure we have mapped out for Unicornshop, I have my dev OU, my prod OU, where my microservice deployments will be, but I also have a second prod PCI OU as well. Now have a think, why would I have a second prod account? And the answer is because of PCI compliance. Now with PCI compliance, there's specific services in the AWS catalog that are PCI compliant. So what we can do with service control policies is we can take a whitelist and a blacklist approach to the API calls that are being called within that account. Now you see in this example, which wouldn't, to be honest, allow me to do too much, allows just the use of EC2 and CloudWatch within that prod PCI OU. So what I can do is make sure that any other services in that account can't be called. And because we're applying this policy at the OU structure, even if I have a full root account access in one of those accounts, then the policy at the OU level trumps any permissions that are then set beneath that. Really cool stuff. Now I also promised you an identity monolith. Now typically we want to decouple the monolith. Large parts of my day are spent working with organizations looking at ways to move away from the monolith. But let's unpack this one and have a look a little bit. So the technology that we're going to be looking into this with is StackSets. Now StackSets as part of CloudFormation allows me to deploy a CloudFormation template across multiple accounts, multiple regions, and even across organizational units. But why would I necessarily want to do this with identity? So to understand this a little bit more, let's look at a common approach of handling identity across multiple accounts. Now typically I have a central identity account and my users assume roles into sub-accounts. Now in this case I have my dev account and my prod account. Now if I want to change the permissions of what those admins have access to in each of those accounts, because essentially I want to have more limited access in my production account than I do my dev account, I have to manually update those roles individually. Now for 2 accounts that's fine, but if I have dozens of accounts or hundreds of accounts, it tempts laziness. Either organizations start reducing the number of accounts that they're using to reduce the operational overhead, but at the same time increasing that blast radius, or even worse, being more liberal than needed with those permissions that are assigned against those roles. With StackSets, however, I can define a single CloudFormation template within my identity account, and when I want to make changes to 1, 10, or 100 accounts, I simply make changes to one template. I can define how the deployment will take place, whether it's specific accounts, specific regions, or via organizational units. And one template means I can store this in a repository for my developers and my admins to make suggested updates to, and then pull those requested updates as part of a CI/CD pipeline. Now this is a great way for decentralized organizations to remove some of the delays around account management. We can then look at open source tools like RepoKit and Aardvark, 2 awesome tools released by Netflix, and again, details on that Unicornshop website, that then help us push towards a state of least privilege by analyzing these roles, and if specific API calls haven't been called in, say, 30 days or 60 days, a time that you define, it will go ahead and then strip those permissions off those roles, driving you to that point of least privilege. So what we're going to do now is we're going to move into a little demo and having a look at one of the requirements that we have for Unicorn Shop. Now, being that they're running PCI workloads here, we want to make sure that all of the volumes within the accounts or within the organizational structure for PCI prod are encrypted. So let's walk through how we're going to do that. So firstly, if we take a look at AWS organizations here, we can see we're in our prod PCI OU structure, and I have two accounts sitting under here. We're going to grab the organizational ID because this is going to be important later once we deploy this out. So we get this started. I'm going to actually go ahead and deploy that stack set now. And the stack set we're going to use is one of the sample ones that we've already got listed in stack sets, which is add config rule for encrypted volumes. We're going to give this stack set a name. And in this second field here, you can decide whether you want to use a specific KMS key or whether you want to just make sure that the volume's encrypted. So if I had a specific key that I wanted to be using here, I could define it here. But in my case, I just want to make sure that they're encrypted. Now this is where we start looking at deployment options. Now this is the power of stack sets coming out here where I can choose to deploy that to multiple accounts, or in our case, we're going to deploy to that organizational unit. Now the region that we're going to deploy to is just Oregon, but again, you can deploy to multiple regions at the same time. And how are we going to roll this out? I can then say, okay, I'm going to just roll out a couple of deployments at one stage to specific regions, and then just do a slow rollout. And then if there's any failures defined by my failure tolerance at the bottom, it will then roll back that deployment. Best practice is tagging, so don't follow my lead here. Make sure that you're tagging all of your resources. Quick summary, and then we're just going to kick off that stack set. Let's take a look at actually what we're doing here. So if we look at one of this is now we're in one of the sub accounts within that organizational unit. And we can see we've got one EC2 instance running, our Unicorn web server. And we've also got a couple of volumes listed. One of these volumes is encrypted and one of those volumes isn't encrypted. So in theory, we have one volume that's compliant and one volume that isn't compliant. We also have the second account. We just go into here, we can see that we have no running instances here. But we can also see that although config's enabled, there's no rules enabled here. So what we're going to do now is go back to our stack sets and just see how that's getting on, see if that's deployed. Just give that a quick refresh. And we can see very quickly that it's already deployed to those two regions. So if we go back into our account now and go across to our config dashboard, we can see here if we give this page a quick refresh, we can now see the dashboard updated, and I have one of my resources that's compliant and one of my resources that isn't compliant. Within the rule sets, I can then see that the rule has been defined. It's called out that there's one non-compliant resource. So for me, it's great to see the power of organizations, stack sets, and AWS config working together to achieve a level of automated governance that's really, really hard, if not impossible, to achieve on-premise. Now moving on, one area we can also tighten up is around networking. Now Amazon Guard Duty is our intelligent threat detection service that can analyze your VPC network traffic. And off the back of this analysis, I want to be reacting. I don't just want another set of logs that I collect and don't check. Now it's great to have it on to be able to check these, but if I can remediate these in near real time, then all the better. So let's build out an example of what that may look like. So let's say we have a user, John. Apologies to any John that's on the line. Let's say John's launched a machine in a public subnet with port 3389 or RDP open to the world. Now Guard Duty will detect any brute force attacks on this exposed service. So what do I want to do about that particular attack? Maybe I want to fire off an alert to a Slack channel, or even more aggressively, completely block any further actions until InfoSec have taken a deeper look. To help us make those decisions, Guard Duty will grade these threats on a scale of 1 to 10. 1 being more on the informational side of things, and 10 being you really want to do something about this now. So what I can do is let's build out a couple of examples here. Now, in this particular first API call that we've got here, what I'm doing is I'm just collecting all of my guard duty logs into a particular log stream. And that's cool. It means I can go and check these logs. The power now comes when I say, okay, well, I want to create a different rule set focused in specific severity ratings. And in this example, 5 and 8. The magic comes in now when we say, okay, I want a specific Lambda function to fire off for that specific rule set. So depending on the severity, I can then take more aggressive actions. I may, if I have some security adverse workloads that I want to make sure that they're super protected, if there is a high severity breach or a problem that's picked up by guard duty, I could potentially lift an entire account into a different organizational structure with a service control policy that blacklists all API calls in it, effectively completely shutting down that account until the security team can check what's going on. Now, bringing in Macy and the power of machine learning, and if John doesn't normally launch resources in this region, Macy, by interpreting normal user behavior through CloudTrail events, can notify you in near real-time of suspect behavior and then, again, build out that automated remediation off the back of that. Really cool stuff. Now, staying in the realm of security, we talked about our single point of failure with our threat management layer, which is currently fronting that CMS system. Now, if you're tied to a specific vendor or comfortable with a specific vendor, then it's likely that they have some of their appliances on our marketplace, and you can continue to use those. Alternatively, you can place AWS WAF in front of your CloudFront distributions or your application load balancers. Now, WAF is our fully managed web application firewall, and it solves a couple of the problems that we face with the initial deployment. This one is fully available across all availability zones within a region. And our partners have done some great work to create managed rule sets. Now, to give you one call-out example of a rule set here, Trend Micro have created a rule set specifically for CMS systems focused on PCI compliance. So you can subscribe via the marketplace to some really, really specific rule sets focused on the particular workloads that you're running, rather than have to continually analyzing threats and then building out those rule sets yourself, which is undifferentiated heavy lifting that we can offload to some of the great work our partners have done. Now, onto our very important plumbing. Now, when we look at deploying our hybrid networking back to on-premise, we need to take a cost versus reliability versus performance approach. Do I want to use VPN, a combo of direct connect and VPN, or dual direct connects? So for Unicorn Shop, we're going to have 2 1 gigabit links. Now, we're going to make sure that we have HA on the customer side. And in terms of termination into AWS, we're going to make sure that those DX connections terminate into different facilities. Now, the reason we do this is, although off of Direct Connect, you can create a VIF that spans multiple AZs across your VPC, if there was a massive service disruption in one of our facilities that completely took out networking, if that affected facility was also linked to the termination point of your fiber, that could potentially affect access to other resources in other availability zones. So if you terminate those 2 links into different DX POPs, it ensures that you have mesh connectivity across to our AWS service endpoints, as well as any other termination points in your account, such as a private VIF to your VPCs. So we have our landing zone, kinda. So there's, of course, a lot that I didn't go through around VPC design, security groups, access control lists, et cetera, but I've provided more details on what's already a really well-trodden path already. So if you're not too sure what the right steps are or some of the best practice approaches to take here, do check out the Unicorn Shop website to really dive into that content. There's some great stuff out there that my colleagues have written about before. Now, most Microsoft applications need Microsoft Active Directory, and that goes for Unicorn Shop as well. So that's a good place, typically in a migration after we have landing zone, to look next. Now, we're going to take a look at a few common approaches before diving in on the approach Unicorn Shop specifically will be taking. Now, the first possible approach for a hybrid environment uses a single Active Directory forest and a single Active Directory domain extending across the Active Directory, Now, it means that you get control over your domain, but also the heavy lifting of managing said domain. Now, you also need to be aware of how Active Directory sites and services work to make sure that users, servers, and applications in AWS are not crossing the wire needlessly to speak to on-premise service for authentication. You also need to be aware of replication lag that will occur when updates are made in a site to replicate to another site. So although this is common for very large organizations, there's still quite a bit of heavy lifting involved here. A less common approach, but still an approach, is actually to create a child domain in AWS off of the main on-premise domain. Now, this can make sense when you want to delegate control to specific groups of administrative users. However, there are better ways to do this if a split of authority is what you want to achieve. In this situation, a dual forest approach may make more sense. And that is our most common approach that I'm certainly seeing when I speak with my customers, to create an entirely new forest in AWS and set up a two-way or a one-way trust between the two forests. And being that managing Active Directory domains is something that typically adds very little value to the organizations you work for, this quickly becomes a conversation around looking at the AWS Managed Active Directory service, our fully fledged AD service, where you get a feature-rich domain and we take care of things like backups, availability across multiple availability zones, as well as patching. Tasks that typically no administrators typically miss. So with Unicorn Shop, the initial approach we're taking is creating a forest trust from our on-premise tin across to AWS Managed Microsoft AD. Now, Managed AD allows us to use existing on-premise users for authentication across that trust if required, and integrate with SaaS offerings such as Office 365. We can federate with Azure AD Connect and optionally ADFS, or a number of other single sign-on solutions, and there's more details about that on the Unicorn Shop website as well. Now, retaining my domain controllers in AWS means my local servers, applications, and databases can authenticate locally, while still providing a feature-rich experience for those SaaS applications. This is an all-in migration with long-term goals of centralized VDI for my users. So I'll be looking at leveraging things like our Work Suite offering, like workspaces in the future. So Managed AD makes sense for really tight integration here as well. The time will come for Unicorn Shop when they want to migrate their users and computers and passwords across to AWS. Now, full details of how this can be achieved are available on a blog article I recently published, which is linked to the Unicornshop.lol website again, rather. Now, at a high level, we'll go through the following steps. First, I'll launch the AWS Managed Microsoft Active Directory service. I'll then launch a domain join client, which is joined to my destination domains. That's, in this case, the directory service. I then configure a forest trust between my source and my destination. Next, I install the ADMT service on the Active Directory Migration Toolkit on the destination domain client and the pairs or the password export server tool on that source domain controller. And it can be any domain controller within that domain. ADMT will then allow us to replicate our users, computers, and groups and other items, whilst PES allows us to replicate any passwords across so that users aren't inconvenienced with password changes. Trust me, lots and lots of headaches here. So I can do this in an encrypted and secure method. So just to recap, we've built out our landing zone. We have networking to support our migration in our hybrid state, and we have our identity layer sorted. Now, typically next is looking at our database layer. And understanding business requirements are a key, as there's a number of options we have here. If I have a small database and a large enough maintenance window, maybe I just want to use a backup and a restore. If I have a large database and potentially constrained network links, maybe I'll look at things like Snowball as a way of shipping that into AWS, seeding that database, and then doing any replications of any small deltas. For Unicorn Shop, they want to make sure that there's virtually no downtime, and they want to be able to test those applications on AWS before they flip over and go live onto those new deployments. So for them, the AWS Database Migration Service makes sense. So this approach with DMS allows us to keep the SQL Server applications running on-premise during the migration of data back across that network link. Remember that there's two fat 1 gigabit network links here, so we're comfortable that links can cope with that data transfer. Now, DMS or Database Migration Service is designed for heterogeneous migrations. So for example, SQL Server to MySQL or Postgres. But it also supports homogeneous migrations or like for like, in our case, SQL Server to SQL Server. So I go through a process of configuring a replication instance that will have source and destination endpoints configured. There's no schema conversion that's required as we're going like for like. So I let DMS create my schema and my table structure for the source SQL Server, and DMS will continue to load data onto that destination database, which can be EC2 or in our case, RDS. Now, when I'm ready to go, and that's not quite yet, we know I have no applications running on AWS yet, I can pause right to my source database, update my .NET Applications connection string, so then point to that new RDS endpoint, at which point I can decommission my database, and you can take it home, hug it, put it in a museum, whatever you need to do. So now, before I do our database flip over, we can look at removing those applications that we designated in our migration approach as rehost. Now, these can be Exchange, SharePoint, Skype for Business, System Center, etc. But for Unicornshop, this consists of their web store and their CMS systems, web and app tiers. Hold the thought on that batch process that we also identified in our first workload. So in Unicornshop, they're running Hyper-V, which is managed by System Virtual Machine Manager. And we're going to launch with the Server Migration Service a pre-created AMI. Now this is basically a virtual machine that we give you. It's a VHDX file, which you'll launch in your on-premise environment. Now this is an agentless approach. You don't have to install agents on each of those machines. But what it will do is it will create an AMI that will replicate across to AWS, and then you have an AMI you can then launch. If there's any updates to those virtual machines on-premise, it will then incrementally replicate those block changes across and update that AMI. Once they've migrated across, I then want to be in a position where I can then launch those AMIs. And I don't want to do this manually. I don't want to be manually launching those AMIs. I want to do this through infrastructure as code for things like CloudFormation or Terraform. Now, the problem I have here is a bit of a chicken and egg problem, is that I want to specify what my AMIs are, but they haven't replicated across yet. So if you check out the website, again, there's a great walkthrough of how you can actually call a Lambda function as part of your CloudFormation launch, which will actually look up your tagged AMI and then map that back to a specific AMID. So that way, if I update my AMI in the future, I don't necessarily need to go back and continually update those AMI IDs in my CloudFormation templates. And there's some great examples of this we'll cover a bit later when we move into a patch solution as well. Now onto our microservice deployments. Now at Unicornshop, the reason they're using Windows containers is for developer experience, speed of deployment, and going directly to serverless is hard. Now, I have a number of customers running Windows containers in production, and my personal view is that this can make sense for full .NET applications. However, with the drive towards .NET Core, and given the more feature-rich container support due to the maturity in this space, look at running .NET Core on Linux hosts to get the best of both worlds and a much smaller container image as well. Should you store state in containers? Potentially, it depends. It depends what your goal is. So for Unicornshop, the long-term goal is to move to serverless. So they don't want to start tying their state up within containers. So they're going to make sure that they're stateless to make that move to serverless a lot easier. How would I migrate these containers? Well, the cop-out answer is containers by nature are portable. So if you don't have a CI/CD process already, then check out the website, which gives you some details of a more traditional and also a more modern approach to how you can create a CI/CD process to help with your container deployments. If you've got some fairly complex deployments for your container workloads and you're just not too sure where to start, then we've got some great partners in this space, AppZero just being one I want to call out here, that have great experience in working with customers that have really customized complex container environments that they want to migrate across to AWS. Now the CFO at Unicornshop has a strong focus on costs, and the business of Unicornshop is not built around container orchestration, thankfully. So a migration into ECS makes sense. And utilizing Spotfleet, they can leverage two auto-scaling groups here. One for on-demand, which they can reserve with reservations, and one using a diversified Spot fleet using multiple instance types. Now, Spot's come a long way from the more volatile product that people are familiar with from a year or more ago. So you can get some great ability to diversify across multiple instances, and Spotfleet will make sure that it's got a healthy mix of different instances so that you don't suddenly have a big impact if the spot market changes. Now, if we think back to our CMS system, we also had a side batch process here as well. Now that executes a batch upload of data from one of our vendors to insert data into our SQL database. So we're going to implement this as serverless. So let's go through the process of why we're going to do this. But actually, firstly, I just want you to understand why we're doing this. The real takeaway here is to just start thinking about how you can start decoupling some processes into a serverless model. You don't have to translate everything, but things like event-driven, something that gets triggered by something, or as a scheduled task required to do it, and maybe it doesn't happen many times during a day. This is a great way to start playing with serverless and finding some real value in your organizations. So now data will be dropped into S3. instead of via directly onto that server. I can define whether my trigger for this data is going to be on a schedule or just on the put of the arrival of that data into that bucket. We're going to then use a Lambda function using our .NET 2.1 code to actually pull data from that CSV file that's uploaded, perform a little bit of ETL and a bit of cleanup if we need to. And then, being that Lambda directly integrates with VPC, I can then do a direct write of data into our SQL database. Now this is great because the SQL database can still stay safe in a private subnet, but it allows my Lambda function to integrate with it directly. Because this is event-driven, I'm only paying for the compute when that process is running, and from a security standpoint, my surface area of attack is completely eliminated all the time that Lambda function isn't being called. So simply out of time, I also wanted to leave you with one example of optimizing on AWS as we move to that off-ramp. And one of the tools is AWS Systems Manager Suite. Now, I never enjoyed looking after WSUS as an administrator, and luckily with SSM, you don't necessarily have to use it as much. Now, one of the solutions that we have available online manages the end-to-end patching of your Windows or your Linux AMIs. In this example, we're going to go through a Windows example here. Now, what this will do, and remember this is fully automated, there's no manual clicking here, this is fully automated. What it will do is it will launch a new EC2 instance either running off of an AMI that you specified or one of our base AMIs. It will update EC2 config or SSM agent, depending on what version of Windows you're running. It will then update the PV drivers, run any Windows updates defined on the aggressiveness that you want to. Maybe you just want critical updates, maybe you want security updates, you can define that. At this point, I can then provide any user invoke scripts that you want to define. Maybe I want to install specific applications or enable specific Windows roles within that server. Then it will run a sysprep and a generalize, which is obviously really important for our Windows workloads, before stopping that instance and then creating a nice clean AMI for that image. Now, if you think back to our method where we're saying we're tagging our AMIs, we're not specifically baking AMI IDs in our CloudFormation template. That way, my CloudFormation templates, if I redeploy those, they're going to pick up the latest and greatest AMI as long as I've got my hygiene retained with tagging. Dole is a great example of one of our customers running a number of SharePoint deployments on the platform, and using CloudFormation and automation extensively, they're able to launch a new SharePoint website in minutes. Now, this heavy use of automation allows them to save more than $350,000 a year in operating expenses alone. So you really want to make sure that you're leveraging things like infrastructure as code and the power of automation to make sure that we're removing a lot of those manual tasks. Now, just wrapping up, once I have my applications migrated across and my microservices running in ECS, I can now look at flipping across my database connection strings to the AWS RDS instance. A DNS update for my Unicornshop.lol records will then see users starting to access those applications in AWS. We can then start on the journey of optimization. So today we walked through the strategy behind a migration, building out our landing zone with a security focus, and making sure we really understand the importance of account structures and how we handle identity. We then seamlessly migrated our SQL databases across using DMS before migrating our applications across in an approach that mixed a bit of refactor and rehost. So to leave you with a couple of closing tips, truly understand the dependency chain in your Microsoft applications as part of that plan stage. Really, really important. So again, leverage things like the AWS Application Discovery Service here. And then build out your migration plan around that dependency chain. Now, we took this approach here, and it allows a much easier transition as we migrate these workloads across. And lastly, a very, very big topic that I simply don't have time for today is to truly understand how Microsoft licensing works on AWS, and then plan effectively in order to make sure you're getting the best value you can for these workloads. Hopefully this left you with some information that will help you migrate some of your workloads across, and please do check that website out and you can dive a lot deeper into that content. Thank you so much for your time.